who don't know ETSI, it's a standards organization. So we deliver standards, European standards that are globally applicable in the domain of information and communication technologies. So it includes emergency communications, indeed, yeah. So the session, we have all heard a lot about next generation 911 and next generation 112. The first presentation is going to be a concrete case about the implementation of NG 911 in the state of Maine in USA. So we will see the transition phase, also the issues they have met and the benefits. The speaker is Maria Jacques, so pronounced in the French way. That is apparently the right pronunciation. So Maria, you're Director of State in the state of Maine of the Emergency Services Communication Bureau, and you're also the President of the National Association of State 911 Administrators in USA. So please.
Thank you. So thank you. It's a real pleasure and an honor to be here today to talk about our migration to next generation 911. So today I'm going to talk about a little bit about the state of Maine to give you kind of a picture of where we are, the reasons we chose to be an early adopter, transition strategies, things we learned from our transition, and immediate benefits that we see today, even though we're not in a true end state NG 911 situation. And then hopefully there'll be time for your questions. So if you look at the state of Maine, we're in the northeast corner of the United States. We're one of the 6 New England states, and the reason why I bring that up is what we have in common is a strong statewide authority to implement and manage 911 at the state level. This gave us a significant advantage to moving from an enhanced 911 system to a next generation 911 system, because I, at the state level as director, and have the authority to manage and implement 911. If you look at Maine, we have a relatively small border with our fellow states, the state of New Hampshire, but a large international border with Canada, Quebec, and New Brunswick. The Quebec side is very rural. There's not many people in the northeast corner of the of Maine. It's a lot of trees and animals, but the New Brunswick border is much busier. There's approximately 1.3 million people in the state of Maine. Our largest city is only 67,000 people, so compared to most of you probably, it's very small. Today we have 24 PSAPS. At the time of our migration, we had 26. Our state system my office manages a statewide contract for 911 services, and we deploy, and they're responsible for all the system elements, but not for staffing at PSAPS, not for the cost of PSAPS. That's managed locally. We'll get to that. I have a state of staff of 9, 4 of which are GIS, which is also a key component of our transition discussion today. And I have a 911 advisory council. Our funding is 45 cents on every service drop for wireline, wireless, VoIP, and traditional local exchange carriers. So why be an early adopter? Well, we were in a situation where we had our enhanced 911 system was aging. A lot of the parts were becoming manufactured, discontinued. So we were in a position where we could put in more of the same or move to next generation, which we had been planning for at the state level for many years, and be ready for the next advances in communication. Like many of you, we recognized the fact that people's communication choices were changing, that enhanced 911 had reached its expansion capability, and we were looking for a more seamless transition or a seamless adaptation of new communications as they come available. Next generation services also offered us more control at the 911 authority level, and it also promised to cost less money. And we'll talk a little bit about all of those in my upcoming slides. So we went out to RFP, and that's a request for proposals, and we had a lot of responses, and we selected Fairpoint Communications, which has now been bought out by Consolidated Communications, and they were responsible for the end-to-end replacement of our enhanced 911 system, all the way from the egress at the legacy selective gateway, all the way through to replacing equipment at the PSAP level. The contract required them to complete implementation within 18 months. Then upon system acceptance, we had a 5-year term. It was arguably the first 911 statewide implementation of the EENA I3 standard. So who were our stakeholders? Well, when you have a statewide system, it's literally every person in the United States, in the state of Maine, plus all our local exchange carriers and other service providers, the over 500 cities and towns. In addition to almost 500 cities and towns, we have 500 unincorporated townships. So there's literally 1,000 municipal civil subdivisions in the state of Maine. We also had the current enhanced 911 service provider that happened to be the same service provider as our new system, but I bring that up because that's a very important part of your transition strategy, is that you need to have a transitional agreement with your current service provider. When you go from an enhanced 911 system to an NG 911 system, you're building and turning on one system while you're continuing to maintain the other. So during that transitional state, there'll be the turning down of one system and the turning up of another. So this is an overview of what our 911 system kind of looks like. We have two redundant data centers. Those data centers are all redundant within them as well. At this point, we had 26 PSAPs. Half the PSAPs were off one data center, and half the PSAPs were off the other. The system is capable and has run off of only one data center. And when you have a core-based system like we implemented, you're essentially, in a capacity like we designed, you're essentially running two large PSAPs with many different call-taking locations. I'll talk about some of the issues that come up with that, which is a change from our old system later on. We have legacy selective router gateways. That's because we have no mandate for carriers to deliver calls IP with location, so we change that to IP and deliver based on geographic location to the appropriate PSAP. So we are capable of taking SIP calls. We do take SIP text calls today. So the transition strategy. Those 5 elements are basically the 5 areas that were going on all at the same time. Different teams were working on that. I only have a staff of 9. We were spread pretty thin. Our service provider, of course, was providing a lot of support. I didn't mention before that the service provider also partnered with Solacom, Geocom, 911 Data Master, and we have Cisco routers doing border control. So the major component to this, I'm not going to read those in the interest of time, was definitely getting your GIS ready. So in Maine, when we did enhanced 911, we had very rural addresses that weren't ready for enhanced 911. They were postal addresses. We had to convert more than half of the state of Maine to the civic addresses, 911 Main Street, 91 Main Street, we used rural style addressing, which means nothing probably to you, so we won't talk about that. But when we did that, we chose GIS as our manner to assist towns with this conversion process. And along the way, we realized wireless came along, we realized the need to maintain it. So we had a pretty robust data set at the state level. That put us far ahead of what many states are encountering today. We started working on, many years ago, standardized, making sure our GIS road segments were the same as what was in our automatic location identification database, so that for every record in the ALI database, there was a corresponding road range in the GIS. But that's just the start of the data project that you get involved with GIS. The standardization of responder names. I mean, keep in mind, we have 500 municipalities, all with the different emergency responders. And what GeoComm helped us with was to review our GIS and set our priorities for our staff. And they gave us, we call it a report card, but it was basically a prioritization list of what we had to accomplish prior to the implementation of NG911 so that calls could route within the system and the system could run optimally. Still today, we're still working on providing structure locations, updating that, and building out that layer. Once we got all the data elements in place, we started provisioning GIS on a daily basis, even prior to the startup of the 911 system, and that GIS was actually feeding daily updates to the legacy service providers to keep their records up to date. So this kind of shows that process. We, at the same time this is all going on, we instituted a new process with towns, which was the electronic reporting of structure and address, new roads and that kind of thing, changes to our staff. They were also dealing with errors, and they provision that daily to the service provider, who pushes that GIS data, those updates, out throughout the system in every place that GIS resides within the NG911 ecosystem, including the desktops at the PSAPS. We also transitioned from one LA database provider to the new one, and we did this prior to cutover, and this was important to transition because this allowed us to have the legacy PSAPS and the NG911 PSAPS using the same database. So that was cared for. That was the first thing we actually did. And we coordinated with all our local exchange providers. We ran dual systems for about a week and then cut over fully to the new database. So PSAP readiness, this is by far probably the most important thing from a people perspective to take care of. This was our third system we'd put in within the state of Maine, but still we went out to every PSAP. We know them all personally, but we reviewed where they were at. Many times you can have things that have changed in their physical plant, electrical and grounding and security are very important to the survivability of a 911 system. We also interviewed them. Every PSAP has something unique, and I think about the one in Augusta, Maine that cares for the state capitol, and they have a ring-down circuit from the governor's office to the PSAP. Little idiosyncrasies like that need to be cared for in the transition, and maybe we'd forgotten over the course of the several years. So a few PSAPs had administrative lines ringing into the 911 system. In the enhanced 911 world, we don't allow that in the NG911 system. And one of the major reasons is for security. Every different instance of a telephone system coming into the NG911 system is a vulnerability. So they were given ample warning about changing over those administrative lines. We do allow arbitration between phone systems, though. We recognize that call taker anxiety was a big issue. We wanted to make the new system look and feel as much like the old system as possible. And even though there were different CPE vendors, we made that screen look as much like the old system as possible. So there are some things, realities of a core-based system. Okay, so what do I mean by a core-based system? Is when in the enhanced 911 world, all the intelligence of the system is in the back room. Very heavy, racks and racks in some cases of controlling equipment. In a core-based system, there's maybe in the smaller PSAPs, the rack is about this big as opposed to 2. And all that intelligence is in the core. And when I talked about the fact that it's like running 2 different PSAPs, there's some customization that's not allowed that can't happen locally that may have been able to happen at the Enhanced 911 system. So what we tried to do is negotiate amongst all the parties. So I kind of maybe you had a relation, think about this in terms of human relationships, where maybe you had to, deal with your former spouse before. Well, now you're not just dealing with them, you're dancing with them, because so many of the things are so integrated in the next generation 911 world, and you have to work cooperatively to manage them. So things like how long should a call ring at a PSAP? We have two different ring styles. We have automatic call distributors for our 6 larger PSAPs, and then we have what's called ring all, which is a smaller PSAPs where a call will come in and ring at every position. So we settled on the ring time at a smaller PSAP would be 36 seconds before it rolled over, and about a minute at the larger PSAPs. And so from a systematic point of view, there were some choices we made that we didn't allow the PSAPs to make from the administrative perspective. And why that is important is when you're trying to troubleshoot an issue, that you know how it should work. There's a way that a call should route, how it should present, and it's easier to troubleshoot problems that are coming in. So the transition process. We turned up the ESI net and tested it in our training center. I didn't mention this yet, but our training center is actually a live PSAP that half the positions, 6 of them are off of one data center and 6 are off the second data center. So we could test pretty much all the requirements of the contract within our training center. And we did what was called regression testing. So what happened is if you get to element number 84 and it fails for some reason and you make the fix, guess what? You start over on the first element and you test all the way through. So that's an extensive process to go through, but it helps make sure that you're prepared for the cutover of PSAPs. So the first PSAPs we transitioned were our 4 default centers. They were state-run PSAPs. And the very first was the default center for the entire system. And when we did cut over, what we had to do was test every backup scenario that center cared for. And in the NG9, in our situation, an NG911 PSAP could back up a legacy PSAP. A legacy PSAP could not back up an NG911 PSAP, but they could still continue to back up what they were doing before. But this meant there were temporary translation routing choices that were made, and we went through, at the time of cutover, every single backup scenario that PSAP performed. So the larger the PSAP, the more time it took. But generally, it was a one-day process. The first few took a couple days. We got better at it as it went along. And once, excuse me, those 4 PSAPs were cut over, we transitioned about 2 PSAPs a month until the system was fully cut over. As we transitioned PSAP, we turned down the circuits on the legacy system. We did have those prepared. In one case, we did go backwards. It wasn't functioning, and I ordered going back to the enhanced 911 system. So you do have to care for that as well. So transitional state. This, for a lot of reasons, needs to be as short as possible. Ours was actually not that long, about 4 or 5 months. The transitional state is expensive. The longer you're maintaining 2 systems, the more expensive it is. There's also, you're maintaining old processes as well as new processes. And I've talked about some of those other situations already. And in a core-based system, the reality is if you discover a problem that's not a critical error, those patches need to wait until everyone's transition, because if you introduce a new patch, into the system, then you've got to test every PSAP that's been cut over already and go and it's a major step backwards. So that's how we prioritize things. The PSAPs, however, that were transitioned first, there may have been some bugs. We're not happy about waiting till the post cutover to get these changes. That was a long time to wait. So lessons learned. So core-based systems issues common to one PSAP are many times common to the other. So at first, people were very excited about the new system, but then it was kind of like the honeymoon period wore off, and the realities of the new system set in, and some problems started to be voiced. PSAPs, we started comparing notes between PSAPs, and some of these sounded very familiar. They may have expressed them differently. But what we soon found out is that sometimes problems associated with one PSAP were common to all PSAPs. And we also found out that as much as we tested and tested and tested, some problems didn't kind of come up until they started to transfer calls amongst each other. And some strange things started to happen. And there was also issues with call takers getting used to VoIP audio. You know, when you listen to a VoIP phone call as opposed to an analog phone call, there's nothing in the background. There's no background noise. And there's also that sensation that somebody can't hear you because they continue to, because when you talk, you can't hear them talking at the same time. So we also got complaints that you must have done something to the wireless call delivery because now we're getting more phase 1 calls. Those are wireless calls delivered without location, only a tower address. And in reality, that was because the system was so much faster that phase 2 location wasn't coming when the call, immediately when the call taker picked up the call. There was nothing wrong with it. It was just a difference in the two systems. However, there really were some true issues. And if I made one mistake, we didn't listen closely enough to our PSAPs. And about midway through, we said, okay, there's something wrong here. We need to get a better handle on some of these issues. So we're about halfway through, but we invited all PSAPs to be part of this. And literally what we did was we went through every single PSAP on the call and said, tell us a list of all your problems. And we listed them. Every spreadsheet had a tab for every PSAP. And then after that first call, we sat down and said, okay, what are the common issues? What are we hearing? They may be said, is this call the same, this problem at PSAP A, the same problem as PSAP B? And we tried to come up with a list of common issues, and those were the issues we went after first to correct. Following cutover, I instituted mandatory PSAP visits so that the upper level people in my organization, we only have 9, so there were like 4 of us, that had mandatory PSAP visits. We spread it out so somebody was seeing a PSAP once a month. And believe it or not, we found issues that the PSAPs were living with. They didn't even realize they had a problem, but by my staff being out there and reviewing what was happening, we found some more bugs. We still do all PSAP calls. We use them for greater than just the system, any kind of training announcements, updates that are coming, if we have legislation that might impact them, whatever the notices are that we need to publish, we use that forum. We don't have any more issues on our issues register. But we also, in the middle of all this, published little training. We called them performance alerts, but really they're just little training announcements on different issues. When we did find out that maybe there was part of the training that was misunderstood, that call takers needed to be refreshed. Or maybe that we put in a patch and it changed just slightly. So we do issue those. Those are all on our website. Look at that if you'd like. So we're getting administrative impact. There was definitely changes in our staff procedures. Every process that we had to process errors and changed. Staff relationships changed. Where we used to have that the E911 database manager sort of fed things to the GIS staff, it now flopped. So GIS was really become what we call the heart and soul of our 911 system. And that, we'll talk about that in a little bit more detail. Management information systems. The beautiful thing about next generation 911 is all the data, because we can actually see at every hop, every step of the call as it's processed, we can see through our management information system. So when somebody calls and says, I don't know why I got this call or how it ended up in my PSAP, we can tell. We can go through and see. And when they say, well, we don't understand why our calls are logging, are going to the next PSAP only 24 seconds into it, and we're supposed to have a minute, well, we can tell. We can see how PSAP, how different call takers are logged onto the system, and maybe they weren't utilizing all their roles effectively. So the GIS staff would definitely experience the biggest change. You know, it became, you know, at first, and maybe you have this experience, you know, the GIS, the map at the PSAP, wasn't considered critical, right? If there was a problem, it could wait till the next business day to fix it. Well, now it is critical. If there is a problem with the GIS, calls may not route correctly. This put a lot of stress. This was a huge cultural change for that staff. And I didn't recognize it right away, but they were afraid to make mistakes. They were afraid of what might happen if they did something incorrectly. We also learned that all processes needed to be documented, and this was a very fluid process. We were all learning too. There's no handbook, every system's different. And we recognized that there were no islands of knowledge. If somebody was out sick, life had to go on, and someone needed to know how to do it. So they provision changes daily. They can just be simple road changes, but there can also be routing changes. And we've instituted a process that our routing changes take place only on Wednesdays. And that's so that we have time to prepare the week before, then we have time to correct if there's a problem before the weekend starts. We do emergency routing changes too, but we try to stick to this Wednesday schedule. I think I've covered most of this. So the benefits of NG911. So obviously, when we turned up the system, all of a sudden video didn't start coming and all these fancy things that you read about in the books. We basically, what I like to say is, we put the framework in place so we're prepared for the future. So we did have some immediate benefits, though. One of the things is kind of an American thing. When wireless calls come into an enhanced 911 center, that police, fire, and rescue selective transfer buttons don't auto-populate. And in next generation 911, if you have a phase 2 location, which is the probable location of the call, the underlying GIS automatically populates the police, fire, and rescue. So in the event that a call was routed to the wrong PSAP, or it needs to be transferred out of the system to a secondary system, they need police, they hit the police button, it'll go to the authority responsible for the dispatch of police. That was probably the single biggest benefit to the individual call taker that this new system provided. It took a while for us to convince them they could trust it. But if you asked them today, they would tell you that that's the biggest benefit they saw. They loved the map, but when they started to understand how intelligent that map was and how it could help them, they adopted it willingly. System access and repair. When we had patches, it used to be we had to roll trucks out. An upgrade might take months to implement by the time you get around to all 26 PSAPs. Minor patches can be done in a day. New releases can be done in a couple. And sometimes there's not even a technician required at the PSAP in order to get it done. So what happened right after we cut over the system was that the service provider, the technicians went on strike. So that was a little scary, but what the system provider realized was just how much they could do without technicians. The I3 logging system, which comes into our MIS. We use Higher Ground. It's very detailed, a lot of analysis. It took us a while to get used to it, but it really is very robust and provides us a lot of insight into the health of the 911 system. And we are achieving cost savings. We are saving approximately $1.2 to $1.5 million a year. And when your old system only costs $7.2 million, that savings is very significant. How we're saving it is the core-based system now. That is definitely where the savings comes from. So a little data analysis, my last minute here. So right after, this is October 31st of 2014, we finished cutting over PSAPS in July. Now we'd always told them about how calls will roll. The calls don't just ring and ring and ring in your PSAP anymore after a certain amount of time, they're gonna go. If call taker's not ready, or it rings if there's no available call taker, the system can see that. It'll send it to the next PSAP. Or if the call rings a certain amount of time, it'll go to the next PSAP. So in the third column, you can see what an average day at the end of October looks like at each of those PSAPs. And this is what happened when we had about 6 inches of snow, very heavy, wet snow in October, and there were a lot of power outages and accidents. And this happened to be a Sunday of all days. It could have been worse. It could have been a weekday. And what you see is in the fifth column, the amount of calls that left the PSAP they were supposed to go to and went to their alternate. And then in the last column, how many calls went to their second alternate. There's actually a few more layers of routing that could have happened. It could have been worse. But what we learned from this was we changed some routing configurations and alternate routing patterns to help them out a little. And we also help PSAPs understand how their logins in their centers could control how long it rang to give them the maximum benefit of keeping that call in the PSAP. So we look at 911 as an evolutionary process, and we have made some changes. We do IP delivery of text. We were doing text to TTY. Prior to that, it was very slow and cumbersome. IP delivery is much more robust. Text can get delivered to one PSAP. If we find it needs to go to another, we can transfer that text call along with the conversation to another PSAP. We also do outgoing SMS. That, I don't know if you have this phenomenon in Europe, but many times people accidentally call 911 and then they realize and they hang up. And then they won't answer a call back from the 911 operator, call taker. But we've found through experience in other states, Maine's experience has been the same, that a lot of people will answer a text back. So that has helped us a lot in that way. We're working on a agreement with New Hampshire to transfer calls across the border with location. We hope to expand that. We are very happy to hear the announcements that Canada had a plan for Next Generation 911, and we look forward to interoperating across borders with them. We are planning on real-time text later this year. We are also evaluating device hybrid AML and incorporating that into our 911 system. Ideally, we'd like to do that the I3 way. So that's what is slowing us down, but we will implement that as an additional location source to what's required of carriers. I think that's pretty much concludes my presentation. And thank you.
Thank you, Maria, for this very comprehensive presentation.
Thank you.
I think we have learned a lot, and mainly that Next Generation 911 can be implemented in the real life.
Thanks.
So now it's time for questions, so please don't be shy. Raise your hand if you want to speak. Introduce yourself first.
Hey, Jerome from France. Thank you for the presentation. How did you manage the relationships with the MNOs? Did you face difficulties implementing your NG911 architecture with the MNOs in your states? like the operators, telecommunications operators.
With the carriers, you're saying?
Yes. Well, I would precise my question. I think the GIS part should be the job of the MNOs and the telecommunications operators. And I think you've invested a lot in managing this GIS part. So I wanted to know if you had connections with the telecommunication operators who have to deliver they need to deliver you the, pardon? They need to deliver the communication to your ESI net. And how did you link with them? Was it difficult? Did you manage a difficult relationship?
Oh, so I'm going to try and repeat back your question and make
Yes.
sure I understand it. So are you talking about how is GIS fed to the state system from the localities? Is that what your question is?
Well, my question is, you have telecommunication operators who have to deliver that service to your ESI net.
Oh, all right.
You need standardization, you have the I3 systems, but I think in France we will face difficulties to communicate and to separate the responsibilities between what the operators have to deliver to the ESI net we want to build and the things we take in responsibilities, okay. And also, especially in terms of routing. So that's my point. How did you manage that?
Well, we actually had a huge advantage here. Okay, so whereas a lot of states may have had several different systems and they're coming together as a state for the first time to the two data centers, to whatever that interface is, we already only had one system before. So it really was an easy transition for the carriers. They really didn't have to do anything, just transition where they're provisioning their daily changes, literally. Because we use legacy selective routing gateways. So we didn't change that methodology. And the reason we chose that was because carriers in the United States aren't obligated to deliver calls IP, likely won't until they're told to. So, at least the wireless carriers, we're hearing some grumblings that some want to try to do that, and we're willing partners for sure. But until such time, the legacy selective router gateway was the easiest way for the continuity of services. We have rules at the state level that they're required to follow for their interconnections to us. Did I answer your question? Okay. Any other questions? Okay, I guess I'm doing great.
Sorry, I have a question.
Okay.
So can you give more details about how the localization arrived to the emergency services?
How the organization arrived at?
Because it goes to the PSAPS, and then how the emergency services get the localization.
I'm not understanding what you're asking. So
with a next generation 911,
yeah,
PSAPS get localization, yeah.
Location.
And then to know where the person who has or persons have an emergency problem, yeah.
Okay, so
to localize the person,
right?
Or persons, yeah.
So when a call comes in, if it's a legacy carrier, like a wireline carrier, of course, we have location, absolute location, pretty confident location on that, and that plots on the map. And the emergency within the selective transfer buttons at the PSAP, if they need to transfer it, those are pre-populated, just like in the enhanced 911 world. In the United States with wireless, we have what's called phase 1 and phase 2, and it's really an I2 solution. It's not an I3 solution. So the call is routed based on the tower location, and in phase 1, the only thing you're getting is the location of the tower that the caller hit. And then if it's delivered phase 2, then you have a probable location. The accuracy is increasing, but we are a rural state. If the carrier is using GPS technology, it's more accurate than if they're using GSM at the moment. So call takers, if they don't have a location, can rebid for an updated location. And then again, the selective transfer agencies are pre-populated. That exercise in determining all those response boundaries in a system that's statewide is huge. And it's a constant maintenance process because, believe it or not, these little towns of less than 1,000 may change responders and not tell us. We're finding out in error reports after the fact. So being able to manage that at the state level is actually better. And I didn't cover this, but we also, being a core-based system, put together some contact lists that were common to the whole state. So every PSAP uses the same contact list. So if they get a call for Chelsea, Maine, and they don't know what PSAP it belongs to, they can go to the contact list and they can select the police, fire, or rescue for that particular town and transfer it out. And we manage that and update it on a as-needed basis. And they have found that to be a huge help.
Thank you, Maria. So with the second presentation, we are going to see how it goes in Europe with next generation 112, and what about the status of the implementation in Europe. So we have three speakers: Cristina Lumbreras, EENA Technical Director, and Luca Bergonzi and Wolfgang Kampichler, which is difficult to pronounce for me. Both are co-chairs of the EENA Committee, Technical and Operations EENA Committee. So please.
Okay, so thank you for the explanation. Finally, we have a first glance at somebody who experienced on his skin the deployment of an NG XXX technology. So, of course, we call it NG112 here in Europe. But the principles are the same. What's going on? Why people are going now towards this direction? Well, because technology is changing. This is something we cannot avoid. Sooner or later, actually sooner than later, we are going to have a transition to IP-based communications. Some of them are already there. We know WhatsApp, Skype, and all these kind of services, they are IP communications. But we also know these are not used for emergency services. And one of the answers that these NG112, 911 technologies are having as an answer is exactly addressing what will going to have happened with the IP-based communication and emergency services. There will be a distinction between old-fashioned communication, GSM, PSTN, and what we know as traditional, to these completely IP-based. They will include multimedia, video, chatting, and all these kind of things, but especially, like we understood in this former example, routing will be a very important element of the communication. So what's going on right now besides this enormous change? Let's go on the other slide. There are already some, let me say, happenings. There are already some activities going around in Europe as well. First of all, during the last 3 years, there have been the so-called plug tests. So specific sessions organized by ETSI at their premises in France, whose scope was exactly to test the components of an EZInet, NG112 or 911 technology platform, to demonstrate the end-to-end operability of this platform, as well as interoperability. So several different manufacturers, vendors, and so on, tested together their technologies to demonstrate that it's a standard, so it may work with any component. We eventually had, in 2018, the first European tender, similar to the one that the state of Maine had some time ago, asking specifically for an NG112 infrastructure based on the EENA long-term definition document that was explicitly stated. So we will have soon a country that will deploy the same technology that we just heard from the example of the state of Maine. And besides that, let me say, there are several activities going on in this environment. In particular, EENA is very active in this period to try and spread the word, make people aware that this is coming. Wolfgang?
Yeah, as Luca said, is it on? Yeah, okay. As Luca said, we had a plug test earlier this year, and here you see a picture of the, let's say, usual suspects. So this is the group picture of the plug test we had in January, and at least you should be able to spot 3 persons that are on stage. Actually 2, easy to spot because of the hairstyle. I think the most important thing here is that we have a nice report that you can access. It's publicly available. So if you get the slides, just click on that page and you get a report. So we did a lot of testing. It was about interoperability testing, so different vendors connected together their elements, the functional elements that are part of an NG architecture. And we did end-to-end testing with several scenarios. We also tested the PMIA architecture integrated with the NG112 architecture. And the first time in this plug test we had conformance testing. So there were test tools available where the vendors just connected to the test tool and did some tests in order to find out if they are, let's say, conform to what is described in the standard document. Yeah, this one is showing a little bit of architecture. So actually, I'm an engineer. I put this drawing into the slides. You see here the elements that we've tested. So we have the border control function. We, as a security measure, we have the routing proxy. We have the ECRF. We have the PSAPS interface. And we also tested with a location information service. And during that plug test, we connected also to EML sources, so it was really great to put all those things together and show how it works. Yeah, vendors provide NG112 components, and they are conform to the standards. So we had a lot of participants with different types of services, of features, elements. And I think most important for this conformance testing is that it's not just interoperability testing. It also ensures that the standards are implementable and implemented correctly. So that's very important because we found out some issues. There were some difficulties in the standards document, so we got the chance to change those. I think there will be other events as well. Doing the same stuff. And regarding to the documents, so actually we have not just one document, we have 3 of them. So the most important one is the technical specification describing the elements and the interfaces that interconnect those elements. We have also a technical specification specifying this interoperability testing we did. So there's kind of scenarios that are described, kind of preconditions, and configurations that are needed in order to do interoperability testing. And last but not least, also a document describing how we envision and do the performance testing based on the standards documents.
Okay, so what are we going to do with all this information? So perhaps you have already seen it on the Next Web or on Twitter. But I have the super news that we are launching a new project on Next Generation 112. So we want really to base everything on the standards that Wolfgang has already explained them. And what is this project about? So we want to test here in Europe, look really to move forward and implement Next Generation 112. We have here some use cases, examples, but of course it can be more things that can be tested. So like full IP emergency communication using video, real-time text, also voice, and from different types of devices. We are also thinking about advanced call routing based on different, not only on location, but also in other type of data. Also to enrich the communication that is and the data that are sent to the PSAPS so that they can have more information And also, why not reverse 112? So that, for example, I'm at home with my home speakers and I receive some messages coming from emergency services. So these are some ideas that I wanted to share with you for the project. Of course, we are open for new and other ideas. So who can participate? So we would like really to have consortia from people from the public authorities, also for private companies, working together and testing next generation 112. And there will be, you need different type of profiles of organizations to make sure that you can test the whole change on next generation 112. So here, really what we want to do is going with all the work that we have done on the plug test to go to the countries, involve the emergency services in the country, and work together and make some tests and show that NG112 really is working. And after the test, why not go on real life straight after. So you can apply now. So just you have to send me an email. Here is my email address, but you have time, so you don't have to do it right now. We will have until the 15th of June. You can apply, you can send the application. So just send an email with the description, the name of the organization, who are the people inside the consortium, what are your ideas on what are the use cases that you would like to include in your proposal, and also that you are based on standards. So from a timeline point of view, as said, you still have time. You don't have to send it right now. We will give you until the 15th of June. So it's, as said, it may be needed that different type of participants are in the consortium. So we understand that it may take a little bit of time. We will do the implementation and the testing from June until March next year. And we will share with you all the results in the next conference, so that we all know what happened with this announcement that we made today. And that's it for us. So,
so thank you. Thank you, Cristina, Luca, and Wolfgang for this very interesting presentation, and mainly about the announcement of the project. So what about the funding?
So here, so this, we really don't have funds for this. So this is something that is an initiative from the companies, from also from the public authorities, really to put some tests together.
Thank you. Any question from the audience? You have understood everything? You don't want to know anything more? So, yeah, maybe I can ask an additional question. So, next generation 112 seems to be a mature technology. So, according to you three, what is missing for the concrete implementation in the European countries?
So, well, perhaps Wolfgang and Luca can add something after, but I really think first to understand that there's a need for changing. So this is something that it's like we don't want to hear that we have to move. And also I think perhaps there are emergency services and public authorities. They are also a little bit scared of change, and I think this is the main reason. Don't know, Luca, if you want to add something.
Yes, well, let's say that the technology is there, like Wolfgang said, the plug test proven it, and actually also the state of Maine proved it. So I don't think that problem is a technological one, but it's more like agreement between different entities. This is not anymore just a PSAP problem. This is a national regulatory authority, telecommunication or carriers, actually, that's the correct word, problem, and PSAPs. So these three elements, and probably even others, ministries and so on, they have to sit at the table and define a roadmap. Because even now we don't have, full voice over IP calls in the very final sense that NG112 is talking about. This will come in a few years' time. Carriers are changing. National regulatory authorities should be aware, and PSAPs as well should be aware. So it's a consultation, right? It's like a round table where everybody sits. The sooner we start having these dialogues in every country, the better it is, because the contrary will mean PSAPs will be unprepared, and all the problems will be upon their shoulders, in some extent. So that's what we want to avoid.
Okay, we have still time for last question. So you want to take your chance to ask a last question? No? Okay, thank you. So I think between the presentation of Maria and what happens in Europe with the status, what will happen, it was a lot of interesting information. And what I liked in your presentation, if I have to remember one sentence, would be NG911 can be significantly more efficient and less expensive. I think that summarizes more or less, yeah. And it's promising for the implementation of NG112. And I hope that in Europe we will learn from NG911 implementation. By the way, in how many states in USA NG911 is implemented?
Well, I mean, a lot of the states are doing it very differently. In the New England states, 5 out of 6 of us are NG911, but that's because of our governance model made it easy for us to migrate. Many states are doing it differently. Their current 911 systems are managed municipal or county-based, and that governance model has to come together, and maybe they're doing it. In some cases, they're building out the ESI net, and slowly jurisdictions are migrating to it. There's a lot of different ways that it's going on, and I see a lot of similarities in what Europe is planning, into how the discussions are going. Right. So, in some states, for example, they're doing regional ESI nets. And then there'll be a state-level ESI net that will connect the regional ones together. So every state, it's hard to measure exactly where people are, but I would say that probably 90% of the states, at least, are on their way and moving forward.
Okay, thank you. So I hope you liked the session. I think we can thank all the thank all the speakers and also the audience, because you're numerous in the room. So I have to encourage you. I don't think you need a lot of encouragement to go for lunch, enjoy your lunch, but mainly, please, if you want to participate to the next session in this room or to another session in track 2, be at 2 p.m. sharp. So in this room, you will enjoy a session on call takers and dispatchers, wellness, mental and physical health, ergonomics. And in the track 2, which is in room A, you will have the pleasure to attend a session on smart cities and Internet of Things. What does it mean for public safety? Interesting. Thank you.
Thank you.
Thank you.